All right, so we are going to be talking about sequences today, and that covers all of section 9.5. So bear with me on this note taking with the dot cam. It's new to me, so I'll do the best I can. So remember, if you have questions on this, we'll be meeting on Wednesdays and you can ask questions. I've given some flexibility on due dates for assignments so that you have time to ask questions if you need them. All right. So let's just start with 9.5 and talking about sequences. So when we talk about at a younger level, and I would say maybe third, fourth grade, you could look at this. Again, that is kind of flexible depending on students. But when we look at patterns, because really that's what a sequence is it's a pattern. All right. So if we have a pattern of something like this, let's say, and then we have these, okay, and then that pattern repeats. So eventually the student can find, that repeating pattern within that. Okay, the first thing that you want to determine is how many shapes are in that sequence. So recognize that right here is when it starts to repeat, right? So we have 1, 2, 3, 4, 5. That's a sequence of 6. Of 6 shapes. So let's say I want to know, well, what would maybe be the 27th term in this? Now I could do 27 of these and just keep repeating until I get to 27, which is kind of that trial and error method. But if I wanted to know the 120th shape, that's a little bit different. So if I wanted to know what is the 27th term, so let's say what's the 27th term? Well, recognize that we're going to have 27 terms. And after every 6 shapes, it repeats. So that means I just can divide by 6, and let's see how many full patterns of 6 we can get. So 6 goes into 27 4 times, which is 24, with a remainder of 3. Okay, so 4 full rotations or 4 full sequences of 6 before it repeats. So we have 4 of those, and then we have 3 more. This is part of that pattern. We have 3 more. So 1, 2, 3. So we're going to end on a circle. So what would that pattern be? It would be a circle. All right. So that's kind of working with these, introducing students to patterns and beginning to introduce them to sequences, which they can begin to do in 8th grade, maybe a little in 7th grade, for sure in algebra in high school. Okay, so let's begin with just the algebra sequence. So talking about an algebra sequence, I'm sorry, I mean arithmetic. So let's start with arithmetic, which is found in algebra. Thank you. All right, arithmetic sequence. An arithmetic sequence is just a list of entries and that are in a specific order. Okay, so it's a list of entries that are in a specific order. Now, when we deal with arithmetic, okay, that's always going to be dealing with finding a fixed number by adding or subtracting. So it's a fixed number by adding or subtracting. For example, let's say we just have a basic pattern of 2, 4, that goes on infinitely. All right, so you can see what that pattern is we are adding 2 each time, right? So it's a fixed number and it's an addition or a subtraction. So what we're going to do is we want to be able to predict what is maybe the 20th term in that pattern, all right, and without doing it by trial and error. So let's start with something like this. Let's say we have a pattern of 9. Bear with me because I haven't done math in a while. Okay, let's say we're here. All right, there's our our pattern. So this is our first term, and maybe eventually we're going to want to find a term over here, maybe the 20th term, maybe 100th term, whatever that might be. Okay. So when we deal with an arithmetic series and we want to find what this pattern is, because we're going to put it into an equation of y in terms of x, we always start with the zero term. And that's really important. So make a note that we always are going to start with the zero term. Okay, start with zero term. So if this is my first term, so first of all, let's see, what is the pattern? Well, I am adding 5, right, each time. So I have found that pattern of the fixed number by adding 5. But keep in mind, this is the first term. And what I want is the zero term. So this is hard for me because I want to say to you, now tell me what the zero term is. But I can't do that, so I guess I'll tell you. So the zero term means it's going to be this number right here. So I guess what we would do is go back and subtract 5, right? So 9 minus 5 gives us 4. So from 4 to 9, we added 5, we added 5, we added 5. So this is your zero term. And when you talk about arithmetic sequences, you always begin with your zero term. So whatever you start with, you got to find that zero term, okay? All right, so let's begin here. So we're going to start with 4. That's our constant. Okay, that number doesn't change. We begin with 4 with our zero term. And then we're going to add 5, right? But this is our zero term, so we're going to multiply it times 0. So 4 plus 0 gives us 4. Okay, then our next term is going, again, we begin with 4, and then we're going to add 5, and this is our first term. So this becomes 4 plus 5, so this becomes 9. Okay, again, begin with our constant there. And then here we're going to have 5 times, this is our second term. So 10 plus 4 is 14, and so forth. So you can kind of see the pattern there. Now this is what I would expect you to be able to write down and show me, all right? This is the work I want you to be able to do, and you're going to need to do on your assignment that I assigned for you on this. So let's then write this in y in terms of x. So meaning let's put it into an equation, all right? So if we want to do that, we're going to have y equals, and we write whatever our constant is. Notice that 4 never changes, that's our constant, okay? Plus, and also what is fixed here that never changes? It's the difference, right? So that's your difference is what we're going to have here, and that becomes a coefficient, and I'll explain that in just a minute. And then notice these vary, right? And they do a constant vary, which is nice. That means it's going to be a linear equation if it's constant, but these vary. So that's where we put in our variable x. All right, so depending on what we put in for x would be what our y answer. So y depends on what x is. So this then can be graphed. And you know what, you can graph however you're comfortable. Some of you might know the slope-intercept form, and some of you may only know the XY table. And it doesn't, you can use an XY table all the time, so that's a good one to use. But if you know how to graph by slope-intercept form, we can talk about that quickly, but I'm not going to spend a whole lot of time on it because I just want you to be able to graph this and recognize that it's linear. And our power here of x is 1, which means we're probably going to have a linear equation unless that variable is in the denominator. And so linear means it's going to be a straight line. Okay, so as you get into the higher level, or even just in an algebra course, you would want your students to write the variable first, all right? And this is called slope-intercept form. And if you remember that from, that is y equals mx plus b. So this m, which in this case is your 5, is your rate of change. Okay, so if I put this over 1, because it's a whole number, this is saying that this is going to change 5 vertically over 1 horizontally. All right, so something like this. It's going to change 5 here, so your y, the change in y is 5. It's a terrible triangle. all right? And then this is 1. So for every 5, this changes 1. Now that obviously is not drawn to scale, okay? So that's your rate of change. And then this is your y-intercept. So if I wanted to graph this, excuse me, something like this, something like this. And again, remember this is a sketch, so it's not going to be lovely. Here's your y-intercept, so we're going to go up to 4, and that's where we begin our graph. Okay, if this number is positive, it doesn't matter if it's a fraction. If it's positive, this number goes up. If this fraction is negative, this number goes down. Doesn't do anything with the bottom number, just bring that negative to the top and deal with the top number. So from here, it's a positive 5. I'm going to put it over 1 because we want it to be a fraction to show our slope and our rate, the rise over the run, change in y over change in x. So from here, we're going to go up 5, 1, 2, 3, 4, 5, and then we go 1 to the right. So 1, 2, 3, 4, 5, 1 to the right. That bottom number will always go to the right as long as you put the negative to the top. So if this were negative 5, I would go down 5, 1 to the right. Okay, and then again, let's sketch that linear line. Okay. Now, if you don't remember slope-intercept form, you can also graph that with an XY or a t-table. And so recognize on this, if I put a 0 in for x here, put a 0 in for x, then I would have 4 plus 0, right? I did that right here. So this becomes 0, so this is 4. If I put a 1 in for x, I just showed that, that's going to be 9. If I put a 2 in, that's going to be 14. Now, if I go on this graph and I just plot these points, here's 0, 4, 1, 9, and then I could do another one up here, 2, 14. It's going to fall on this line, and I would still have that linear line. So you can graph it with a table, or you can graph it with slope-intercept form, whichever is easier for you. Okay. All right. So let's do another one. Let's try another example. Let's say we have. Let's go with, this isn't really creative because it's kind of similar to the last part, but that's okay. All right, so let's say we have, oh, there we go. Let's say we have this, let's say we have this pattern. Okay, again, first of all, figure out what is your pattern. And I know, real creative on my part, it's +5 again, okay? So we see that difference. But remember, this is your first term, and we have to know our 0 term. So what is our 0 term going to be right here? Well, we're going to go back, so we're going to go a -5 here. So 3 minus 5 is a -2. So we begin with a -2. If you can read that in there. Okay, that's our 0 term. So now let's go and do like we did up here on our, let's find this pattern that we have right here. Okay. So we are going to begin with our 0 term at -2. And then we're going to add, this is our constant, okay? And then we are going to, what are we doing every single, and I don't want you to get confused and put a -5 here, because when I go from here to here, that is a +5. This is a +5, this is a +5. So that's what we want to use, is we want to use a +5. So don't get that confused that when you go backwards, it's a -5. Because we're going from left to right from the 0 term, and we're adding 5 every term, okay? So that's going to be 5 times 0. And then, so that's a -2 plus 0 would be a -2. All right, then we keep this constant, and our fixed rate, our fixed change here is 5. So 5, our first term. So -2 plus 5 would be a +3. Let's just do one more. -2 plus, now we're doing our second term, -2 plus 10 would be 8. So our pattern, just be sure we have our pattern correct. So let's write an equation of y in terms of x. So y is equal to, okay, what our constant is, which is a -2, plus, okay, what is our fixed change, +5, and then our variant here, it's our variable. Now you can write it like that, and I will tell you on your assignment, it's written both ways. So be sure you can recognize it written both ways. If I want you to write it specifically in slope-intercept form, I'll tell you. Otherwise, I don't care which way you write it. They're both correct. This just leads us into more of the graphing. So let's say, all right, so then tell me maybe what is the 20th term? So what is the 20th term? Well, that's going to be y equals a -2 plus 5. So our 20th term, we're going to put a 20 in for x. So this is 100, so -2 plus 100. So y is equal to -2 plus 100, what is that, 98. So our 20th term in this pattern is going to be 98. Okay. All right. So let's look at this maybe at a little bit more of a maybe with in a high school level that you might get, or even in 8th grade when we start talking about sequences. I'm not sure that you wouldn't maybe see it in the 7th grade. You probably could see it in the probability maybe in 7th grade, but let's talk about the high school sequences for an arithmetic sequence. So here's the formula. Okay. And you will need to memorize this. We're not going to go into depth with this like we normally would, just because we don't have as much time since we've lost class time. We normally would go into the summation formula and work it that way, but we just don't have time to do that. So I feel like if you can recognize this level as an algebra level, then you kind of see where students need to go, beginning with these patterns that we talked about right here, working your way from here, right, to finding the pattern, to writing the equation y in terms of x. So this problem right here that we're doing at the bottom, we can do the same problem, and I'll show you how we can do that using this equation or formula, excuse me, here. So a sub n, this is really what is your nth term that you're looking for. So maybe in that case that our last problem was the 20th term. So that's going to end up being what your y value is. Okay. And then a sub 1, my goodness, a sub 1, this is going to be whatever your first term in your pattern is. Okay, that's your first term from your pattern. This is the number of terms that the term that you're looking for. So if I'm looking for the 20th term, I'm going to put a 20 in there. And then this is the difference in your pattern. And that's the fixed difference, okay, in the pattern. So let's go back to this one that we just did, and I'll go ahead and put in the 0 since we already had that and found that. Because the 0 really doesn't do too much here. I mean, because we're not trying to find the equation, we're just using a formula. So you have to remember that this is your first term, okay? So, so we're going to find what a sub n is. We'll leave it as a sub n right now. And then our first term here is 3. It's easy to put a -2, so be really careful there. And then let's say we want to find the 20th term. So if I want to find the 20th term, I would just put a 20 here because n means 20. So I'd put a 20 here. And then what was our difference here? Well, our difference is a +5, so a difference of 5. So let's work that out. So our 20th term is going to be 3 plus 19 times 5. So it's going to be 19 times 5. Okay. And so that would be what? Times 5. 95. All right. 3 plus 95. So a sub 20 is 98. Well, that's exactly what we found in our last problem that we did here, just finding the equation in terms of y and substituting it in. Okay. So one thing I didn't write on here that I'm going to just show you real quick, just so you recognize, we put a 10 in for x. I'm sorry, we put a 20 in, my fault. We put a 20 in for x right here. Oop. 20 in for x, and y was 98. So recognize That's an ordered pair. So ordered pair 2098 is going to fall on this line that I graph. All right, just recognize that. So it's the same thing as the table. Put a 0 in for X, it was 4. I put a 20 in, it was 98. Okay, the same thing. All right, so this is just showing you using this formula. You can do it exactly the same way. Okay, I'm finding a term. All right, so that's our arithmetic sequences. So let's go ahead now and move on and talk about the geometric sequence. So geometric is really kind of similar to what we're talking about with arithmetic, because it's still dealing with a fixed ratio, but it's dealing with multiplication and division rather than addition and subtraction. All right, so when we're so it's going to be a fixed ratio, and I say a ratio because if we multiply by 2, it's the same thing as multiplying times 2 over 1, or maybe we want to multiply times a fraction or divide by that. So that's why we use the word ratio. So it's fixed ratio by multiplying or dividing. So what you have to do is recognize, well, what is the pattern? Okay, well, if I'm multiplying or dividing, we're going to use a geometric sequence. If it's adding or subtracting, that's going to be an arithmetic sequence. So let's say we have a pattern of just this. All right, so if we have that pattern, do you recognize what's happening here? I mean, I might look at this and go, oh, I'm adding 6, but if I add 6 here, that's going to give me 18, so that's not correct. Well, I can multiply by 2. Okay, here to here. Well, I can also multiply by 2. Recognize that that is consistent throughout, all right? So we have a constant fixed rate of multiplying by 2. So when we write a geometric sequence, it's written like, here is my first term, and then here is my second term, here is my third term, here is my fourth term, and so on. And let me kind of show you what that means exactly. So when we begin, now the difference here with the geometric sequence is we begin with our first term. We don't have to go find the 0 term. But what we are finding is when our ratio, our rate, okay, let me just write this out so you'll see it before I say that. So we would have 6 to find our first term, we'd have 6, right? And then that's what we begin with the first term. And then we're going to, what we're doing, we're multiplying by 2, okay? And this is our first one, so we're going to put it to the 0 power because 2 to the 0 power is 1. So that gives us 1, so that's going to be our first term. All right, so it's a little bit different that we begin with our first term here. Now let's do the next one, 6 times 2 to the 1. So 6 times 2, so we're going to have 12. 6 times 2 to the second power. 6 times 4 give us 24. 6 times 2 to the third would be 6 times 8, 48. So you see our pattern. I guess I could go ahead and just do this, but all right. So what we're really doing on that is, let's see if we can find an equation of y in terms of x. So y is equal to our fixed constant, which is 6, okay, times, okay, what is this fixed term here that never changes is 2, but what does vary is this power. So that's where our power varies. We don't know what that's going to be. Okay. So this right here, this 2 to the x, that shows us that it's going to be exponential. And I'll show you a graph of that here in just a second, okay? So if I wanted to find what the 10th, well, let's go low, what the 10th term is, I would have to put a 10 in here and say 2 to the 10th power times 6. So let's take a look at this graph because I want you to be able to see. So this one is a little more difficult to graph by hand because your numbers get so large. Like I said, if x is 10, 2 to the 10th power, you know, that's 2 times 2 times 2. That's quite a bit, and then times 6. So that can get to be big numbers that you have to graph by hand. So here's Now, do I have this up here? Let's see. Okay, well, let me just go here. I can do it here. Okay, so here is Desmos. This is a Desmos graph, and it's desmos.com, and you can get on the graphing calculator. This is what I use in some of my college algebra courses and such. So you can graph these and take a look. If you have a graphing calculator, that's totally cool too. But let's go ahead and graph what we're looking at here. So we're going to graph 6 times 2 to the x. So I'm going to do 2 to the x first, all right? So 2 to the x. Now, I don't know why I always use that one, but I do. If you choose this one right here, you can put in what you want. It doesn't come up with 2. 2 to the x, okay? And then you got an arrow here, and then times 6. So this is the equation we just found. Well, take a look at this. Let me move this out of the way. Take a look at this exponential. Do you see how fast it grows? So here is where we begin at 6, right? 0, 6. And then it just continues to grow really, really, really exponentially. And you can see how fast that grows. So, you know, there's a lot of exponential growth in populations in some countries. The wolf population in Yellowstone, that was another big deal when they introduced the wolves. And you know, I know it's kind of a bummer to talk about, but what's going on in our world today, that's so crazy. You know, the infections are coronavirus infections are growing exponentially. And so that is where you will see a type of exponential graph like this, is something like that. So anytime you see a graph with an x in the variable, you're going to have some kind of an exponential graph, or it might be an exponential, it may be a growth, or it might be a decay as well. It could be either one, all right? So let me go back to our notes, and let's try another one of these, and let's look at this one. Let's do this example. All right, so what we're doing here, as you can see, I hope you can recognize that, is that we are multiplying by 1/2 for each of these. All right, so we're multiplying by 1/2. So if we want to try and figure out what that pattern is going to be, all right, so what is our beginning term? We just go with our first term. So we have 1/2, okay, times whatever our ratio is, our fixed ratio. First one's to the 0, and that gives us 1. So 1/2 times 1 is 1/2. Okay, then our next one is going to be, again, 1/2, whatever our ratio, fixed ratio is, to the first power. So this is 1/2 times 1/2, multiply straight across, and we have 1/4. Let's do one more. So we have 1/2 times 1/2 squared. This is going to give us our third term. So this is 1/2 times 1/2 times 1/2. So that becomes 1/2 times 1/4. Okay, so multiply straight across. Oops. Multiply straight across, and that gives us 1/8. Okay. So we see we have the pattern. So y in terms of x, so we have y is equal to, okay, whatever our constant that we began with is, which in this case is your first term, times our fixed ratio, which is 1/2. And this is what varies, right? This power is what varies, so to the x. So let's take a look at what that might look like on our graph. So instead here, if they'll let me, we'll make that a 1/2. You can use your keyboard too on this if you want to. You don't have to. Okay, and then here is 1/2. So let me bring it in a little bit, move this out of the way. So look what's happening here. So this, as x gets larger, the y variable is getting smaller and smaller and smaller. Okay, so that's an exponential decay. And if you ever talked about when you were in your algebra classes, how that never crosses this 0, right? That's an asymptote, but we won't go there right now. But just recognize that that's an exponential decay because it's decreasing. So when you have a fraction there, that's going to decrease. Okay. All right. Now you can always do an XY table with that, right? And put an XY table in and graph it that way. So keep that in mind. So for over here, that was kind of small, I'm going to put in, this is what we would do for a geometric in the high school or in an algebra class, maybe an algebra 2 class. Geometric series is A, okay, our beginning term, and our ratio with n minus 1. That's an n minus 1. And that's because notice on our ratio here, just like we do, it's our first term. So we put a 1 in there. So 1 minus 1 is 0. And then our second term, we put a 2 in there, 2 minus 1. So that's why it's n minus 1. That's why that's the formula. And, you know, we're not going to take the time to prove that. We just don't have the time to do that, unfortunately. So keep in mind here that, keep in mind here that, let's see what I want to say here, a r to the 0. That's your first term. Okay, oh, get that over there. That's your first term. All right, you guys, that's our lesson today on sequences, arithmetic and geometric. So I will post a worksheet for you to do on these by tomorrow, and they will be found in your chapter 9 folder on pages, view all pages. And honestly, the best thing that I can come up with is just when you finish it, take a picture or scan it and email it back to me. That way you still have a copy of your homework, all right? And then I can grade it, and and we'll be able to talk about that on Wednesdays if you have questions about it as well. But be sure you get them in on time. I gave a lot of flexibility in the due date, so you have some time to do this and ask questions, okay? And also, if you would, you know, just please be considerate of the fact that I have, you know, over 100 students, and they're all going to be sending me emails of assignments and tests, and it's going to be a little crazy, and I do the best I can to stay on top of that and get everything organized. And but just stay on top of your grade. Be sure, you know, the grade goes in. If it doesn't, let me know. I'll have the email and I'll save it, I promise you. So I'll do the best I can with that. But we'll talk a little bit more about that on Wednesday. So we will see you at the open discussion on Wednesday. All right, guys, have a great day.